Algebra Lesson 8-1. We're now going to switch gears away from linear concepts and start thinking about exponential concepts. So today's introduction begins us into what we would call product of powers, the exponents. To multiply powers with the same base, now the base is the big number, just add the exponents together. So for example, if you had 3 to the second power and you wanted to multiply that product by another power, then they have the same base, you keep the same base and add the exponents. That would make it 3 to the 9th power. For example, let's say the 3 to the second power looks like this. That's 3 to the second. And let's say 3 to the 7th looks like this. And you know that according to this problem, you're multiplying that 3 to the second times this 3 to the 7th. So there's a big multiplication right here. Which means you're really having 1, 2, 3, 4, 5, 6, 7, 8, 9 threes all multiplied together. But that takes a lot longer than understanding if they have the same base, meaning the same bottom base big number, we add the exponents. One of the biggest mistakes that people make is they'll take this 3 and multiply it by that 3, and so they'll end up with 9 to the 9th power. We do not want that. Another mistake is people will multiply the 2 and the 7, so they end up with an answer of 3 to the 14th power. You've got to be very careful that if you're multiplying the same base, you add the exponents together. So that's when we have the product. Product means the multiplication of exponent powers. Now, this is a little bit different. This is power of a power. So this one is saying you have 5 squared, but then that is taken to the 4th power. If this is happening, where it's a power of a power, now you do multiply the exponents. But you've got to recognize there's a difference between this and this. They are not the same. What's happening down here is you have 5 squared. And 5 squared really means 5 to the second power. But we have 4 of those. We have 4 5 squareds. So we have 5 to the second power, 5 to the second power, and 5 to the second power. So there's 4 5 to the second powers. But in between these is also multiplication. So you really don't need the parentheses at all. You don't need them because it's all multiplication. So 1, 2, 3, 4, 5, 6, 7, 8 is 5 to the 8th power. Just to clarify, that 5 to the 8th power does not mean 40. It's not 5 times 8. 5 times 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 5 is obviously not 40. If it were all addition, then it might be 40, but not if it's multiplication. So we have product of powers and we have power of a power. They are different, and you've got to make sure you understand the rules between them and why they are different, what's actually taking place. All right? There is also one more. It is known as the power of a product. This one gets confused with product of a power because it's reversed, it's flipped. All right? So what it's saying is there's an exponent involved with this product. You find the power of each of the factors and then you multiply. So here's what we have. 2 numbers inside are being multiplied together, taken to an exponent. It's like the distributive property. You can give that m, that exponent, to both the values inside the parentheses. However, be very careful. If you ever see it as addition, then you cannot give it to both of them. You can't say, I'm going to give the m to the a and the m to the b, so it's a to the m plus b to the m. That does not work. It only works if in here it's multiplication. It must be the power of a product, not the power of a sum. So you've got to watch that. That's a very common mistake. All right, so we have 3 different situations. We have power of a product of a power, and then we have power of a power itself. Our first example, let's try it out. Here we have 4 to the 5th times 4 to the 3rd. Since they have the same base, we know we add the exponents together. So that makes 4 to the 8th power. So we're simplifying it down. That does not make 32. It's 4 times 4 times 4 times 4 times 4, 8 times. Right? This one sometimes tricks people because they're not quite sure what to do with this 2. Anytime you have a number by itself, you can always write it with an exponent of 1. Because it's basically saying you have 1, 2. So that's 2. And then that's being multiplied by 2 to the 6th power. So that will become 2 to the 1 plus 6, which is 2 to the 7th. So you have 2 to the 6th being multiplied by 1 more 2 would be like 2 to the 7th time. So these two situations are actually examples of product of powers because they have the same base, so we added the exponents together. Right? Here we have product of powers. Power of power. So we know that we're going to take 5 to the 2 times 3, which makes 5 to the 6th power. Common mistake is people make 5 to the 5th power. They accidentally add the exponents together. Right? A little trickier. Now you've got negative 2 being taken to the 3rd power, and then again to the 4th power. So this is going to be negative 2 to the 3 times 4, which will make negative 2 to the 12th power. Again, the exponents are multiplied together. You keep whatever's inside the parentheses. That answer may or may not change if there are no parentheses around the number. So that's power of a power. And we can make this 3 to the 2nd times 4 to the 2nd. In other words, it's like the distributive property. We can give it to each of the values, just making sure that we multiply the values when we're done. So 3 squared, if you wanted, you could say that's 9 times 16. And 9 times 16, 9 times this 10, 9 times 10 is 90, and 9 times 6 is 54. When you add 90 and 54 together, you get 144. That happens to be the exact same value as 3 times 4, which is 12. 12 squared is 144. So that proves that having the power of a product actually works. Applying it here, we would give this 4 to all the pieces on the inside, and we would end up with 3 to the 4th, x to the 4th, y to the 4th. And if you wanted to, you could convert this into another number and say, or 81 x to the 4th, y to the 4th. 3 times 3 is 9, times 3 again is 27, times 3 again is 81. All right, one more of these. You've got to be very careful about the negatives that's involved. Now, this actually represents negative 3y times negative 3y, because it's being squared. This entire thing is being squared. If you look at your multipliers, you have multiplication here, and multiplication there, which means the order no longer matters. You don't need the parentheses. And you could say that's negative 3 times y times y, because of the commutative property of multiplication. And a negative times a negative makes a positive. So you'd have 9y squared. Or you can give the squared to both values on the inside, here and here. You just have to make sure that it's negative 3 that's being squared and y that's being squared, not just negative of 3 squared. That's different. That could come out to negative 9. This would produce 9y squared. Same answer, different way of getting there. You can either break it all the way down, or you can take the distribution, because it's multiplication inside, it's the power of a product. Okay, now it starts getting a little bit more complicated because you have to compile all the rules, or some of the rules, at one time. I'm not going to do anything with the y to the 5th to begin with. I'm going to distribute this exponent that's on the outside to each of the numbers on the inside. Now here that means I'm going to have 3 squared, and this is a power of a power, so I'm supposed to multiply those. That becomes x to the 8th, and then 2 times the 1 would be y squared. So anytime I distribute and there's already exponents, I have to multiply them because it's power of a power. Then I'm multiplying the y to the 5th, which means these are like parts. They have the same base, so I should add the exponents together. My final answer is 3 squared, x to the 8th, and then y to the 7th. Now you could say, or 9, x to the 8th, y to the 7th. It's the same answer whether you keep it as 3 squared or 9, whichever one you'd like. All right, trying that again. There is no operation symbol here, so that must mean multiplication. And I'm going to give, there's a 1 on that y, so I give the 5 to the 1 here and also there. So I'm going to get 2 to the 5th power, x to the 10th power, y to the 5th power, times x to the 6th power. And because it's multiplication here and here, the commutative property allows us to multiply in any order we want. I can multiply these two together and they have the same base, which means I'm going to add the exponents. So I get 2 to the 5th times x to the 16th, y to the 5th. And you can leave that answer as it is, or if you'd like to simplify 2 times 2 times 2, think about it. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's 5 2's. So you could say 32x to the 16th, y to the 5th. Either answer is okay. The diameter of a small pizza is 6 inches, and the diameter of a large pizza is 18 inches. So most people, given this situation, would say, well, if that's 18 inches and that's 6 inches, then that pizza is 3 times larger, because 3 times 6 is 18. Now, that may or may not be true. Right? It is true that 3 times 6 is definitely 18. The question is, how many times bigger is the large pizza? Well, if you find the area of the small pizza, you'll have A is equal to pi times the radius squared. That's how we find the area. In this case, the radius is not 6, the diameter is. So if diameter equals 6 inches, then the radius is equal to 3 inches. So on the small pizza, the area is 3 squared, so that makes 9 pi inches squared. On the large pizza, if the diameter is 18 inches, then the radius is 9 inches. So you would come down here and you would say that the area for the small or the large pizza is going to be 9 squared, or 81 pi inches squared. So that's how much total area you have on the small pizza. That's how much total area you have on the large pizza. How many times bigger is 81 than 9? It's 9 times bigger. So the question asks, how many times bigger is the large pizza? It's actually 9 times bigger, not 3 times. But we are talking about square and area, so 3 squared makes 9. Find the ratio of area of the large to the area of the small. The area of the large was 81 pi, and the small was 9 pi. Since you have pi on top and bottom, they cancel out, and 81 over 9, they're both divisible by 9, so the ratio is 9 to 1. And that fits our 9 times. The ratio is 9 to 1. Alright? Creating a statement about the effect on the area having 3 times the diameter. 3 times the diameter equals 3 squared times the area. Quite a bit more area by doing that. Alright? A multiple choice test has 2 parts. There are 4 to the 3rd ways to answer 3 of the questions. So 3 questions, 4 possibilities, A, B, C, or D. And those are the 4 choices. And there's 4 to the 7th ways to answer 7 questions with 4 choices. So that's 7 questions, A, B, C, D choices. How many ways are there to answer all 10 questions? 4 to the 3rd and 4 to the 7th, they have the same base, so you can add the exponents, which makes 4 to the 10th. That does not make 40. 1,048,576 possible ways to answer this 10-question test. If you were to guess, what's the probability of getting them all correct? 1 in over a million. You're far better off studying for a multiple choice test than relying on your guessing skills.